All right, we have a difficult lesson ahead of us. This page alone, this slide alone, really confuses people. So for a minute, you need to go back to Algebra 1, and you see we have a function here, kind of like mx plus b. So let's say we have some variable x, and I want to transform it. Maybe I want to add cost into the number of items I sold. So maybe x is the number of items I sold, and y is my profit, or something like that. I don't know. Maybe I'm converting one variable to another unit of measurement. Who knows? But it requires adding a constant or subtracting. That's implied there, because what if that constant is negative? Oops. Or it may involve multiplying. And if b is a fraction, that implies or dividing. I feel like the second concept, multiplying, is easier to wrap your head around. Because if I multiply every number by something, it's going to affect the overall mean, and it's going to affect the spread. Because every number is going to change a little bit differently, and it's going to spread the numbers out differently. And obviously, it's going to enlarge the mean or make it smaller. Adding a constant, concept number one, you know, if I have a graph, it does it best. Let's say I have this graph of values, something like that. All these dots, they have some numerical value. And I add 5 to all of them. Then I'm going to pick all of these up, and I'm going to move them 5 units to the right. Won't they stay the same distance apart from each other? They're just going to be shifted 5 units right. That's why down here there is no effect on spread. That is so crucial that you remember. So if I just add a value to every number, it has no effect on spread. It definitely does affect the mean. The overall mean is going to rise. And so will the median and all that stuff. But spread is not affected. So we need to remember that. All right. We're going to back up a little bit, do some basics that we already know, and then apply what we just talked about. So first off, we need the expected value for Pete's Jeep tours. He's taking a different number of passengers on any given day. There's the proportion of times he takes that many passengers. When I do expected value, I go E of x equals each x times its probability, and add in between. Whoops, no, that's right, sorry. I'm zoomed way in and I couldn't see what I had just written. Barely enough room. Writing too big, probably. So for expected value, when you do that, when you type it in, you get 3.75. And the units for the mean is the same. Here, let me add this symbol. The units for the mean is the same as the units for x. So this is passengers. All right. Standard deviation. We've only done that one time before. It's a little annoying to do, but we have to do it. We go x minus the mean, square it, times x's probability. And you do that for each x and add in between. So you guys try the next term. Whoops, I totally messed that up. It's not 0. Sorry, viewers. You're like, I don't know what you're doing. That should be a 2. All right. Sorry about that. Now I'll try the next term. Should be 3 minus 375, square it, times 0.25. I'm going to do dot, dot, dot for the middle 2, and then do the last term. You guys try and write the last term. Hopefully you wrote that. So this right here squared is called the variance. The variance is 1.1875 when you add all that up. You got to square root it. And then you have the standard deviation. 1.0897. So the next part of the question adds in cost. How much money Pete is going to collect. So if you wanted to, I'm looking at how we could adjust this table here. We could we could add a row. I think you have room for this. I don't know, you might want to redraw this. Looking at your paper, you have room to the right, so you might want to redraw this. I would call this row C and this row X. So he's charging $150 a passenger. That means when he has 2, he's going to collect $300. Right? Here, let me write that down. 150 times 2, 300. 150 times 3 is 450. Think you know now what this looks like. The probabilities do not change. So that means when he brings in $300, that's 15% of the time. So I'm going off of this, if you were lost a second ago. He's charging $150 per passenger. There's this formula you can use instead of redoing the mean of C and the standard deviation of C. So this right here, first of all, probability distribution of C, that's asking for this box. I didn't have room, so I just drew it right there. But then, right below it, I'm not going to erase because I want to be able to see everything. It asks for the mean of C and the standard deviation of C. So, I mean, one way to do this is you could go 300 times 0.15 plus 450 times 0.25 and redo the expected value. It's the same concept. But if I write all that out, all those terms, can't I just factor out a 150 and do it faster by writing this down? Just taking that mean that I found earlier and multiply it times 150. It's a really nice shortcut to doing the mean of a linear function. So you go 150 times 3.75, and we get 562.50. Same concept applies to standard deviation. Technically, you're supposed to write absolute value of that coefficient times the standard deviation of x. We'll look at that here in a minute. But we go 150 times 1.0897, and we get 163.46. you could walk back through the table, 300 minus 562.50, square it, times 0.15, do that 4 more times, and you would get the same standard deviation I just wrote down. So all I'm trying to show you is that this is a really nice shortcut, and that formula is printed later in the handout. I'll point that out. All right. Let's make it a little more complicated. I already answered all that. I'm going to write them again up here because I'm going to need them in a second, I believe. You have them already. You don't have to rewrite this. So now we see that it's going to cost them some money to do a trip. It's going to cost them $100. That V function is $150 per customer minus the cost of the trip. So we need to write down, first of all, the probability distribution. And this one, I have a ton of room, so I'm going to do it right here. If I was doing this from the very beginning, I would write down all my variables, and then lastly, the probability. And I know that X is a repeat of what you have at the middle of the page, previous page, sorry. We already talked about C. That's where we go 150 times each X. The new variable is profit, because he has to pay for this trip. So we lose $100 every time. So the mean for this thing, let me finish this out, sorry. All right, the mean for this thing is very, very similar to what we did a second ago. Once again, if you wanted to do this by hand, you could go 200 times 0.15 plus 350 times 0.25 and so on. Keep adding, and you'll get the correct answer. But a nicer way is to go mu v equals 150 times mu of x minus 100. So I already know what that first term is. I know if I flip the page, look at the bottom, it is 562.50. So really, all you have to do is subtract 100, and that is the mean profit. Look at principle 1 on the very top first page of this handout. And it says that adding a constant or subtracting a constant does affect the center. But the mistake people make is it has no effect on spread. So for standard deviation of profit, I actually need to completely ignore the minus 100. So all I need to do is take my answer from the last page and copy it down. It is 150 times 1.0897, which was 163.46. If you're curious, the formulas for these two things are not, well, they're on the next page of the handout, but we're not going to get to it today. if this is my function right here, then I know the mean of y is b times mu x plus a. I know the standard deviation of y is the absolute value of b times the standard deviation of x. These are not on the formula chart. And that is one reason why this is a difficult handout, because these formulas are not on the formula chart. All right, that's all we did today. See you next week. Bye.